Here's number 9, the solution stoichiometry review. I would say probably the most difficult question on there. So it's telling you you're mixing these two solutions together. It does give you the net on the equation. I did go ahead and write out the full, as most of you usually like. So it's telling you how much you have of these two things. Tells you molarity and liters, molarity and liters. So we can figure out moles right away. There's going to be excess of something. It wants to know the mass of precipitate formed. So we got to figure out grams of this. There's a precipitate that would be formed. And the concentration of all the ions left in solution that'd be left in solution. Well, that's aqueous, that's aqueous, that's aqueous. This is a solid, okay? Potassium ions and nitrate ions are spectator ions, so however many of them are there at the beginning would be there at the end. Their concentration will change because we're now mixing together two solutions, get a bigger volume of solution. So first thing, let's figure out our limiting reactant. So if we multiply molarity times liters, gives us moles. So we have 2 moles of this and 3 moles there. So our limiting, it is a 1-to-2 ratio. This needs to be double that. It's not. So our limiting then is our KOH right there. And our excess would be copper nitrate. So at the end of this reaction, if we think about things that are happening here, all of the nitrate ions that were there at the beginning will still be there at the end. There's still, so we can figure out how many moles there are of nitrate ions, divided by liters, get molarity. All of the potassium ions will still be there at the end because this will still be aqueous. All of the hydroxide ions will be out of solution in the precipitate because it is part of the limiting reactant. So I know the concentration of hydroxide ions will be 0 molar. Concentration of OH negative, I can tell you right now, concentration of OH negative will be 0 molar. It will all be in this solid precipitate. We go from there. So first thing, maybe we'll figure out our grams of precipitate that are formed. So from our limiting reactant, we know that there's 3 moles of KOH that are being used. Ratio is 2 to 1. For every 2 moles of KOH, there's 1 mole of CuOH2. And a mole of copper hydroxide is 97.5 grams off the periodic table. So we'd make about 146 point something grams of copper hydroxide. So that's your mass of precipitate that'd be made. There's one question. All right, now I gotta figure out molarity of everything that's left over at the end of this reaction. Well, you're gonna have some potassium ions. Let's figure out those right now. So we know that there was 3 moles of this compound, 3 moles of KOH at the beginning, which means there was 3 moles potassium ions. So there's still gonna be 3 moles potassium ions. So our concentration of potassium ions is going to be 3 moles of those ions divided by 1.5 liters plus 0.5 liters, 2 liters of solution equals 1.5 molar K plus ions. Concentration of Cu is going to be a little tougher because some of the Cu went into that. There's excess Cu still floating around. So let's say that for the end. Concentration of nitrate ions. Well, there was 2 moles of this compound, but for every mole of that compound, there's 2 moles of nitrate ions. So there's actually 4 moles of nitrate ions floating around in 2 liters of solution. So that is 2 molar for the nitrate ions. And our copper ions. So we need to figure out how many copper ions, how many moles of copper ions are still floating around in solution. Well, we know we used 3 moles of this into 2 to 1 ratio. So if we use 3 moles of this, we're going to use half of this then, or half of that amount. So if this one's going down by 3, this is going down by 1.5 because it's a 2 to 1 ratio. So that means that there's 0.5 moles of copper nitrate, really of copper ions, still floating around in solution. So our concentration of copper ions, 0.5 moles of copper ions in 2 liters of solution is 0.25 molar. That's really just an ice table I would have set up. You know, this is going down by 3, so that's going down by half that, down by 1.5. You have 0.5 moles left over in 2 liters of solution. Again, the other 1.5 moles of copper went into this to make that solid precipitate.